Right, I haven't done a third question in a long time, so let's see how this goes. Okay, show that this can be written as this. So basically, that third, the irrational thing, has come off the bottom. And this is sometimes called rationalising the denominator. So if you're going to revise this, that's what it's called, rationalising the denominator. Because a root is irrational, means it's a decimal, it just goes on forever, and we've got rid of that. So that's what we have to do. So there's a clear method for this, and again, when there's a clear method, it's one of those things you can just learn. Okay, I've taught people of all abilities to do this, you just got to follow the processes. So, you times by this base, but you do not keep the same sign in the middle. Okay, it relates back to difference of two squares, but if you keep that as a plus, you will not eliminate the root on the bottom. Okay, they will not cancel out, as you'll see in a minute. Okay, so let's have a look. Let's get these on the go. So this is what we've got. We've got that on the top, that on the bottom. Okay, so 3 plus root 2, 5 minus root 8, 5 plus root 8, and 5 minus root 8. So let's work them out separately. Let's do the top, let's do the bottom, bring them back together, see what we've got. So 3 plus root 2, 5 minus root 8. This way I'm going to do my proper way. So 3, 5 minus root 8, plus root 2, 5 minus root 8. So it's going to give 15. When you times a root and a number together, they just go together. So 3 root 8, add 5 root 2, because again they just stick together with a number at the front. And then here, the roots, the numbers in the roots actually multiply together, and the signs is just like normal, so positive and a negative make a negative. That's root 16. Okay. So now, what I'm going to do is just simplify this up a little bit. So 15. Well, let's see what I've got. So yeah, let's just work out bits and bobs. So 15 I'll keep for now. I'm going to simplify root 8. So root 8 is actually 4 times 2. Okay, so that's actually going to be, if I take this, square root this 4 and bring it out, that's actually going to turn to 6 root 2. Okay, this is simplifying a third, so that can be a separate thing. Plus 5 root 2 minus 4. So now I've got 15 take away 4, which is 11, which is looking good. I've got minus 6 root 2, add 5 root 2. So just think about 6, add 5, it's minus 1. So it's minus 1 root 2, but you don't need that 1, you don't need it there. So that's the top of my fraction. Okay, not a lot of space, quite tight on this one. Probably because I wrote it there, you probably start working out here. Now I'm going to do this bottom one here, so I'm just going to do that here. So 5 minus root 8, plus root 8, 5 minus root 8. 25 take away 5 root 8, add 5 root 8, minus. Now when you multiply the same root together, you get that number, because it becomes root 64. But when you square root 64, it's the same as 8. So that's what you get there. Let's simplify. Minus 5 root 8, add 5 root 8, they cancel out. Had we kept that as a plus, this would not have happened, and we'd have had plus 10 root 8 or something like that on the bottom. We would not have lost those roots, and we would not have gained this. And 25 take away 8 is 17. So that's the base done. That's the top one. Let's put them back. Done. Okay, so we've proved where it came from.